I welcome you all to this another interesting screencast. We are going to be solving this engineering problem, and it reads, replace the loading system by an equivalent resultant force and specify where the resultant's line of action intersects the member measured from A. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right. So first things first, let's find the components of this particular force system, because we have also some inclined forces. So let's resolve them. We have that one there. We also have this one here up to there, like so, and like so. Right. So what are these? We have this one is 100 by 4 divided by 5. This is equal to 80. Then we have 100 by the run 3 divided by 5. 5 into 100 is just 20. 20 by 3 is a 16. Then this one is a 50 sine 30. We know what sine 30 is, just half or 0.5, therefore this is 25. Then we have a 50 cos 30, which we are going to leave like this. Right, so let's locate this position, an arbitrary position. See, just arbitrarily, so that we just have an idea. Let's put it somewhere here. Okay, we can put it somewhere here. See, just an arbitrary distance t. We call it d, and then let's call this particular resultant. And this resultant, since we have two components here. In the previous case, we only had one component, which was just in the y. Here we have two components, so therefore it means we are going to call this as FRY, okay, because we have x and y. All right, so let's do that. So let's begin the work. So we'll say FRY times d is going to be equal to summation of moments about point A. All right. Let's find what these are. So we have summation of forces in the y going up in our reference, and this is going to be equal to our FRY, which is equal to, we have a 200, we have a minus 80, and we have a plus 50 cos 30. Right, and this gives us 200 minus 80 plus 50 cos 80. 50 cos 30. So we have a 163.30 pounds. Let me check it again. 200 minus 80 plus 50 cos 30. 163.30. Then we have summation of forces in the x going in this direction as our reference. What do we have? In this case, we have two components. We have a 60. We have a 60 plus 25, and this gives us 85 pounds. All right, so now let's bring that equation. So FRY times T is equal to summation of moments. Let's just go directly without bringing this. So let's say summation of moments about point A and clockwise being our reference. We are going to have a positive moment 200 by 3. Then we'll have a negative moment which is 80 by 6. Then we'll have another positive moment which is a 50 cos 30 by 9. Okay, this is going to be equal to, that's 200 by 3 minus 80 by 6 plus 50 cos 30 by 9. This is going to be equal to 509.71 pounds feet. So 200 by 3 minus 80 by 6 plus 50 cos 30 by 9, 509.71. So that is the moment which is anti-clockwise or positive. Right. So let's find what is FYD. So using that equation, using this equation here, which we're just going to show using the arrow instead of writing it down. Using this equation, so we'll say FRY is a 163.30 times D is equal to summation of moments about point A is a 509.71. Therefore, if we calculated our D will be equal to 509.71 divided by 163.30. So we get a 3.12. A 3.12 feet. Okay, so we could call this one as equal to 3.12 feet, and this one equal to 163.30 pounds. Are we done? We are not. We said the resultant, so we need to use Pythagoras since we have two components. So the resultant force therefore is going to be equal to square root of the x component, which is 85, plus the y component, which is 163.30 squared. And once we calculate this, what do we get? 85 squared plus 163.30 squared, square root of that, we have 184.10 pounds. Okay, I just redo it again quickly. So 184.1 if you rounded it off. So that's the resultant. So let's draw what we are talking about. So I'll draw the first case and then I'll equate it with the other one. Alright, so what we are talking about is this. So let's say we have the first beam like so, and then another beam like so. Let me just copy this one. Let me place it somewhere there like this. Okay, there we go. So these are supposed to be equal, and this point is A, and so is this point. Right. So we have we found the component in the y. Let's say the component in the y is somewhere there like that. Component in the y. Of course, the direction here. What is the direction? The direction here changes. Sorry. This direction here is supposed to change. I almost forgot. This direction has to change here. It is this time around facing up. Alright, so we have this resultant like so, and we calculated this to be equal to 163.30 pounds. And then we do have another component because forces, translation forces have got that property of transmissibility. They can move along their line of action. So we're able to move this particular force in the horizontal direction and bring it here. Okay. I could have aligned it with a beam, but I just wanted to bring it up here for visibility's sake. Alright. So this one is equal to 85. And the distance from A to where the vertical component is, this one we said is equal to 3.12 feet. But we can again find the resultant, right? We can find the resultant, which we've done. Okay. So rewriting this, just using one resultant force. Let's use green. How many cells? 1, 2, 3. Somewhere there. So let's say, and we also need the angle, right? We cannot talk about resultant without the angle. So tan inverse of the component in the y, which is a 163.30 divided by 85. This gives us, what's the angle? 163.30 divided by 85. Tan inverse of that, we get a 62.50 degrees. 163.3 divided by 85, 62.5 degrees. So our resultant is going to be at this point, and it will be something like that. Let's just assume something like that. Alright, and the value of this particular force we said is 184. This is the resultant, 184.10 pounds. And the angle, this angle here, which we just calculated, is equal to 62.50 degrees. And the value of D measured from A, we said, still remains the same, which is going to be equal to, this is equal to 3.12 feet. This is about it, really. This is about it. We have found the resultant which intersects the beam at 3.12 feet measured from A. I think this is really about it, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.